Okay, so looking at page 142 in our student journal. So we are going to do number 1. So first thing we do is what, guys? Multiply by 2. So we get x to the 5 halves equals 32. And now to get rid of the 5 halves, we have to multiply by the reciprocal, which is 2/5. So what that means we have then is 5 halves times 2/5 is just going to be 1. And this is going to mean that we have the 5th root of 32 squared. So the 5th root of 32 is 2. Square that, we get 4. Over here, we subtracted 28 rather. So we have 6x plus 10 to the 7/3. 156 minus 28 is going to be 128. So now I need to get this to the first power, guys. So what are we going to raise both sides to? 3/7. So now I'm going to have 6x plus 10 equals, and we have the 7th root of 128. What do you think it might be? Take a guess. 2. Let's try it. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. You were right. So the 7th root of 128 is 2, then to the 3rd power. What's 2 to the 3rd? 8. So solving this then, 6x equals -2, x equals -1/3. We're just going to plug that in and make sure it works. 6 times -1/3 is -2 plus 10 is 8. Cube root of 8 is 2. 2 to the 7th was 128. Plus 28 is 156. Check, it works. All right. Solving inequalities. Okay, we would solve these just as if they were equations. Just the same way. So I'm going to subtract 3. And I have -4 radical x minus 1 equals -4. Oops, not equals, greater than or equal to. Now, I have to divide both sides by -4. Does anyone remember what happens if we divide by a negative? Yep, we got to switch it. So it's going to be radical x minus 1 is now less than or equal to 1. Maya, what do I do next? Square both sides. And I get x minus 1 has to be less than or equal to 1. And x minus x then is going to be less than or equal to 2. So this is telling us then any x less than or equal to 2 is going to work. But let's check a number less than 2. What about 0? What if I plug in 0? 0 minus 1 is -1. What's the square root of -1? I. We're trying to stay away from i's. We don't want to have i's. So therefore, this answer is not quite right. Here's what else we have to do. We have to look at what's underneath that radical, and we have to say that's going to have to be greater than or equal to 0. Because if it's not, then we're going to start getting imaginary numbers, which we don't want. So what is x going to have to be greater than then? Greater than or equal to 1. So now I have two things happening. Yes, x does have to be less than or equal to 2, but it also has to be greater than or equal to 1. So here's the way I write that. I got to think any number that's greater than 1 but less than 2 would have to look like this. My x value has to basically be in between 1 and 2. It has to be greater than 1, but it has to be less than 2. So a really small window in there, like 1 1/2, 1 1/4, 1 3/4, 1 5/6. Those values would work, but nothing else would. If I wrote that answer in interval notation, it would look like that. Okay? Now think about this. What if the answer had been, instead of x less than or equal to 2, what if the answer had been x greater than or equal to 2? And then I looked at this and I said, well, x also has to be greater than or equal to 1. Would I really change anything if my solution is x has to be greater than or equal to 2, and then the domain says that x has to be greater than or equal to 1? No. If I say choose a number greater than or equal to 2, and the number has to be greater than or equal to 1, if both of those things have to be true, I would just say this one, right? I'm not going to say both. So keep that in mind when you're working on your homework. What are we going to do here, guys? Cube both sides. And so then I'm going to have 2/3 x plus 1 is less than 216. 2/3 x is less than 215. Multiplied by 3/2. X must be less than. That's going to be 645 over 2. And I'm going to look at my domain. I'm taking a cube root. Does it matter if it's negative under there if I'm taking a cube root? No, it does not matter, does it? So therefore, I don't have to think about anything else. This is my answer. That's it. Negative infinity to 645 over 2. Anything in there is going to be a solution. Okay? Any questions so far? All right, number 15. First of all, we're going to add our 39. So we have this. Now what are we going to do? Divide by 2, so we're going to have the square root of 3/4 x less than or equal to 7. Now what? Square both sides, 3/4 x less than or equal to 49. Multiply by 4/3. That's going to be x is less than or equal to, that's 196 over 3. So I would say any x less than or equal to 196 over 3 is going to work. But look back up here, it's a square root. So whatever is under that radical is going to have to be greater than or equal to 0. So that means if I multiply by 4/3, x has to be greater than or equal to 0. So I need to check this. I want numbers that are less than or equal to 196 over 3, and they have to be greater than 0. So that's going to go back to this kind of thing again. All of my x's have to be in between those values. That, or like this, in interval notation. Okay? So make sure you don't forget to do that. Check that domain. If it's even root, we have to be greater than or equal to 0. If it's an odd root, we don't care. It can be a negative under there. All right, last thing here. In basketball, the term hang time is the amount of time that a player is suspended in the air when making a basket. To win a slam dunk contest, players try to maximize their hang time. A player's hang time is given by the equation T equals 0.5 square root h. Real similar to your homework problem, right? Except they had kangaroos and something else on that one. Where T is the time in seconds and h is the height in feet of the jump. The second place finisher of a slam dunk contest had a hang time of 1 second, and the winner had a hang time of 1.2 seconds. How many feet higher did the winner jump than the second place finisher? Well, let's look at the second place guy first. So what am I going to do to find the height of the second place person? You may know what we're going to do? Yes, what are we going to do, Charlie? Yeah, so T is 1. And so now we'd have to divide both sides by 0.5. What is 1 divided by 0.5? 2, yes. It's really 1 divided by 1/2, so it's 2. Equals radical h. Now we just square both sides, and we get 4 feet. Not sure that's a realistic vertical jump. I don't know. Do people have 48-inch verticals? I played basketball in high school. I was nowhere close to 48 inches, but I don't know. Maybe those NBA guys do. I'm not sure. All right. So there we go. So there's the second place person. Let's go to the first place. Same type of thing, except this person had a hang time of 1.2 seconds. Divided by 0.5. So what's 0.2 divided by 0.5? 2.4, good. Then we're going to square both sides. Now to square this, I'm going to think of 24 instead of 2.4. 24 squared I know is 576. So what is this going to be then? If 24 squared is 576? 5.76. That's the only thing that's realistic. Because 2 squared is 4, 3 squared is 9. So it's got to be that. And so there's the height of this first place person. And then it just says how many feet higher. So of course that's going to be subtracting those two, 1.76 feet higher for the first place guy or woman. Okay? Any questions over any of that? So again, all we're trying to do is we get rid of everything. We're trying to get this to be a 1, so we have to raise to the reciprocal power, and that's going to do it. When you're doing the inequalities, make sure you're careful about the domain. Square roots have to be greater than or equal to 0 under the radical. Cube roots, we don't care. It can be a negative under there. Yes?
When you did the radical to like greater than or equal to 0, like why did you put that?
Well, I didn't really, because see, this is saying x has to be greater than or equal to 0. This says the same thing. X has to be greater than or equal to 0. In other words, 0 is less than x. So x is greater than 0. See, not Matthias?
No, when you set it up as equal to 0.
Yeah. It always has to be greater than or equal to 0 because we don't want it to be negative. That's the reason why. Anybody else have questions? Okay, good questions there. Okay, so your homework's on the board and on your assignment sheet.